Let's talk about inverse trig functions now. In this chapter of our book, we're learning about transcendental functions. So we learned about the exponential function, we learned about logarithmic functions, and now we're ready to learn about inverse trig functions, which is another type of transcendental function. Okay? So we know that in order for a function to have an inverse in the first place, it must be 1-to-1. We know that, right? Let's take a look at our sine graph right here. So this graph is y is equal to sine of x. And when we look at the graph of this, if I were to draw a horizontal line, we can see that this horizontal line is actually going to intersect our graph twice. So what do we know? We know that sine of x, this is not 1-to-1. So what we want to do is we want to restrict the domain so that it is 1-to-1. So let's take our red highlighter and we'll restrict the domain from negative pi over 2 to pi over 2. And if I restrict the domain from negative pi over 2 to pi over 2, then this means our sine of x is 1-to-1 on that restricted domain. Let's do the same thing for the cosine graph. So again, I take this horizontal line here. We can see that when I look at this horizontal line, it's going to, again, the horizontal line test tells us that it's not 1-to-1. So that means I'm going to have to restrict my domain again. Let's say that now this time I'm going to go from the x value of 0 all the way down to the x value of pi. In other words, I'm going to restrict the domain of my cosine graph. This time we're going to go from 0 to pi, and on this interval, cosine of x is 1-to-1. Lastly, let's take a look at the graph of tangent of x. So I try to run my horizontal line test again. Draw a horizontal line here. We can see that our curve, again, by the horizontal line test, we can see that it's not 1-to-1. It crosses the graph of tangent multiple times. So what we need to do, just like before, is we need to restrict our domain so that we're going to restrict it from negative pi over 2 to pi over 2. And now that highlighted piece is the restricted domain. And what we see is that when we restrict the domain, we see that from negative pi over 2 to pi over 2, our tangent, graph y equal to tangent x is 1-to-1. So I want you to notice that I put round brackets at negative pi over 2 and a round bracket at pi over 2. And that's because we have asymptotes at those two values. So your function will never be defined on those two lines. Those two parts are where the function is undefined. So once I have these 1-to-1 functions, I can create inverse trig functions. So let's take a look at our inverse trig functions. If you take a look at this blue graph right here, this blue graph represents our restricted domain. And this red graph right here, this red graph is going to represent our inverse trig function. So we know that the graphs are related by reflecting across this line, y is equal to x. So let me label everything here. The green line is y is equal to x. The blue line is the restricted y is equal to sine of x. And then the red graph is going to be given by, we sometimes write it as sine inverse of x, but the way that I like to write it is I like to write it as arc sine of x. So you'll see me write that more often than not. So we'll put y is equal to arc sine of x. The reason why I like that is I really don't like how this -1 power here kind of looks like an exponent. And I don't want you to think this is a reciprocal. This is an inverse trig, not reciprocal. So maybe I should write a little note here. This symbol means inverse, not reciprocal. Okay. So when I look at the domain of F inverse, the domain of F inverse should be the same as the range of F. So the domain of F inverse should be from -1 to 1, because that's the range of the sine graph. And the range of our arc sine graph should be the earlier restricted domain that we had, which was from -π/2 to π/2. Okay. Let's do the same for our cosine graph. So I can see I have a pretty major typo here. I mean cosine inverse of x, and we could call that arc cosine of x. All right. So again, this picture is very similar to before. The dotted green line is y is equal to x. Okay. The blue graph was the restricted y is equal to cosine of x graph. And the red line is going to be the inverse function, which is y is equal to arc cosine of x. And we could see, I hope, that if we took this blue graph and we interchange the x and y values, in other words, we flip across this line y is equal to x, then you're going to get this red graph, right? So as I mentioned earlier, we're going to call our inverse arc cosine of x. The domain of this graph is going to be the range of the original graph. So the range of our original graph went from -1 to 1. That was the range of cosine. So that becomes the domain of arc cosine. And the range of arc cosine would be the domain of our original graph, which was the restricted cosine graph. So that was going to go from 0 to pi. Okay. Finally, let's look at the arctangent example. Again, I made a typo here. This sign should really be a tangent. An arc sign should really be arctangent of x. So by now you guys are used to the story, right? This is y is equal to x. That's the line we're going to reflect across. The red graph was the blue graph was my restricted tangent. So this is y is equal to tangent x. And the red graph is my inverse. So that's y is equal to arctangent of x. Now I want to draw special attention to those asymptotes that we have. So these horizontal asymptote, this first horizontal asymptote is y is equal to pi/2. And the second horizontal asymptote we have is y is equal to -pi/2. This. Okay, so our inverse is going to be named arctangent of x. The domain is going to be the range of tangent, which is all real numbers. So this is going to be from negative infinity to positive infinity. And the range is going to go from -pi/2 to pi/2. But we don't want to include these two endpoints because we have horizontal asymptotes now. So we're going to end things off by looking at a couple of limits. If I look at this red graph and I take the limit as the x values go to positive infinity, I hope you can see that it looks like we're going to go to pi over 2. So we could put a pi over 2 over here. Same thing if I went to negative infinity, so if I were to look at the graph and they go off all the way to the left, where does that look like it's going? That looks like it's going to negative pi over 2. So these two limits show up over and over again in our class here. So I'm going to highlight these two limits just so that to draw special attention to them. Okay. So this finishes our introduction to inverse trig functions. I guess the key idea is we had to restrict the domain of our original trig functions in order to talk about the inverses. So you got to keep the domains and ranges in mind. All right, everybody, take care.